Hello guys, have a nice day to everyone. In the previous video which I was upload, I discussed question A of the question number 1. This is from the final past paper. Subject is engineering mathematics. First one, it's something about method of contradiction, the proof method. Okay, and now we are going to discuss part B of question number 1. It's like before the proving method. This time they have asked proof by case. Okay, so I will read for you the question B. Using the proof by case, if any positive integer n, then prove that 2n square plus 17n plus 37 is not divisible by 3. අපිට ක්‍රමයක් ඒගොල්ලෝ දීලා තියෙනවා. මොකක්ද ඒ ක්‍රමය? proof by case. හරි. එතකොට මේ proof by cases කියන්නේ මේ සඳහා විකල්ප පරීක්ෂා කිරීමේ ක්‍රමය තමයි භාවිතා කරලා තියෙන්නේ. එතකොට before the answer the question, you should know one thing about numbers. Okay, something about the numbers. Every number in the world when divided by 3 will either have a remainder of 0, 1 or 2. Okay, every number in the world. So we have to prove at 3 cases. Case 1, numbers that divided perfectly by 3. Case 2, numbers with a remainder of 1. And case 3, numbers with a remainder of 2. Okay, දැන් මම කතා කරමින් හිටියේ මේ ලෝකේ හැම සංඛ්‍යාවක්ම දැන් අපිට අවශ්‍ය 3ෙන් බෙදුව විටනේ. 3ෙන් බෙදුව විට හැමතිස්සෙම එක්ක ඉතුරුව නැතුව බෙදෙනවා. ඉතිරියක් නැහැ. ඒ කියන්නේ බිඳුව. නැත්තම් එකක් ඉතුරු වෙනවා. නැත්තම් දෙකක් ඉතුරු වෙනවා. I will show you the example for this. Like if we consider case 1, numbers that divide perfectly by 3. Perfectly mean after the dividing it's not have a remainder. Okay, like number 6, 9, like this. With this explanation I will move forward. Now we are going to the answer, the math part. The case 1, as I before told you, case 1 is n equals 3k. This 3k means what? The numbers like 3, 6 or 9. So after the considering, when we plug 3k into the statement, what's the statement which they have given in the question? 2n square 17n plus 37. 2n square. Now we plugged 3k into the formula. 3k square 17 3k. So now have to simplify the algebra. Okay, Now we can get 3 to outside from the brackets. Okay, so there is 1 at the end, it is the remainder. So we can consider, since there is a remainder of 1, the total is not divisible by 3. You should understand. Okay, since there is a remainder of 1, the total is not divisible by 3. So first case, now we already done. Now we have already done it. Case 2. Now case 2 means when n equals 3k plus 1. 3k plus 1 represents 4, like 4, 7, 10 numbers. Okay, simply I simplify the algebra. 3k plus 1, 4, k is 1. 3k plus 1 equals 7, k is 2. Okay, as we before simplified. Now again we can plug 3k plus 1 into the formula. 3 first I try to write the previous formula. Now 3k plus 1 square, 17n. N means 3k plus 1. So this time we have a remainder of 2. Again, this means the number cannot be divided perfectly by 3. Okay, if the number can divided perfectly by 3, then there is no remainder. No remainder means 0. Okay, here should be 0, but there is the remainder of 2. Okay, now the second case we have already done. Now case 3, go to the next page. Case 3. Now after doing the math, the formula simplifies to this. So just like in case 1, we are left with the remainder of 1. So the final conclusion, by checking all these possible cases, we have effectively checked every single positive integer in every single scenario, the result had a remainder, like 1 or 2. So therefore, we can conclude that the expression which they have given in the question is truly not divisible by 3. So I think you have clear understand about this discussion. You can watch the video again by again to understand this. So that's it, guys. See you soon in the next video. Have a nice day, everyone.